Hello there, my name's Vince from My Mate Vince, and here is day 8 of the Amazon Advent Repair Challenge. Hopefully you've enjoyed the first 7 days. Let's see if day 8 will be successful or will it be a massive failure. Let's find out.
Fancy fan heater.
Here we have a fancy fan heater. Not only does it oscillate left to right, it also oscillates up and down as well, which is unusual. Haven't seen that before. Anyway, when I turn it on, it is turning on. The remote control doesn't appear to be working. That could be because maybe this is for a different model, or maybe the battery's gone on it. But there's no, although it's oscillating, there's no air coming out, and I've only left it on for 5 or 6 seconds, but I can feel there's heat. It also smells a bit of burning because there's no air passing through the elements, I presume, to cool them down. So I'm only going to turn it on for a few seconds. I'm going to put it down here. You will see it will come up with L2, or you might not. Let's do that now. L2, it's made the noise. Let's press oscillate. You can see it's doing that way. If I do that way, it will go left to right, but there's no, hopefully you can hear, there's no air coming out. I'm going to turn that off, but I can feel heat. So that's what's wrong with this. Let's see if we can get the motor working to push the air through, and then maybe we can fault find this to see why this is not working. But I don't know how long I'm going to spend on this, because I don't even know if this is definitely the remote control for here. Let's take it apart. To me, it looks new, so I can't imagine it's going to be anything too major. I'm going to say that there's probably a loose wire in it. So it looks like you can... And what's this here? Oh, that looks like a thermostat there, and that's a little filter, so that's nice that you can change that out. Well, I'll leave that out. Let's take it apart and see if we can find anything obvious. I can see actually the big fan going through here. So if we zoom in on that, we should be able to just confirm that it's definitely not working. Let's go to the bottom bit of it so you can hopefully see the fan here. Just going to plug it in one more time and turn it on. Ah, did you see that? It turned for a second. Zoom in more, hopefully you can see it. You ready? I'm going to turn it on now. No, didn't turn on at all there. Let's turn it off, unplug it. I'm going to try to drain the power from it. Now turn it on. Let's see if it spins for a second. Yeah, spins for a second and stops. Hopefully you caught that in camera. Let's take it apart. Okay. Now we have to make a decision. Are we going to go to the back? Actually, first of all, let me see if the battery's flat on here, because maybe this has been in storage for a long time. Battery might have drained. So I think these are 3 volts. Yeah, so yeah, it's low, but would have thought maybe that would have worked. Anyway, we can worry about that later. Are we going to go in from the back or underneath? Let's see how this is spinning. Well, I mean, that seems free to me. So the very fact it starts and stops is a bit odd. I think I'm going to start underneath. Let's see what's going on. So this is for the oscillation, plenty of grease, and a little micro switch to let it know that it's at the end of the travel. The connection must be going up through here, so I don't think we need it to actually do anything here. So what I'm going to do is, so it must go up one of the arms. You know, this cable must go up one of the arms in here. I think I'm going to put this back together here just with a couple of screws. I don't think we need to do anything in there. Right, let's undo all these screws at the back. Right, that's all the screws out. Ta-da! We're in. Okay, now, why are you not working? So this is the motor down here. So it's one of these ones that has the core on the inside. Can you see? So is it only getting power? Is it only getting power for a split second? What's going on? So this is the oscillation here, up and down. Then we have a load of cables up here for the display. That's spinning very freely. I wonder how much voltage that motor is. You know, I wonder if I can put power in from my bench power supply to get it working. Is it AC or is it just going to be, is it going to be DC? It's going to be DC, I'd say. Got some massive relays here. Well, I can't see any loose wires. And I can see it says 12 volts on the board just here. So maybe I might try my bench power supply straight in the fan. I'm not saying it is 12 volts, but if you look here, it does say 12 volts here. And that's the connector for the fan. So if that rail was 12 volts, I think 12 volts is going into the fan. We probably would have to take the board out, but just in case it's a motor problem, I wonder, because I might not be able to fix this. If the motor's gone faulty, if the windings or something in the motor's not working, then I might not be able to fix it. I think I'm going to take this out. There we go. I think I'm just going to try to put 12 volts in here. Well, no, I'll do lower to begin with. Let's just do 5 volts, see if we get any life out of this. Because if it's AC mains, I don't think putting 5 volts DC in is actually going to cause any problems. So I'm going to go up to 5 volts to begin with. And 1.2 amps. I'm going to take out the leads from here, so I can use the probes on here. Right, here we go. Let's see if you are going to spin or not. So there's 5 volts coming out of my bench power supply. I've got the positive from my bench power supply going into the red wire feeding the motor, and I've got my negative from the bench power supply going into the black wire feeding the motor. Right, nothing there. Right, so there's no current being drawn, no nothing. Let's up it to 8 volts. Oh, hold on. There is a circuit board under here. I hope it's not some weird brushless motor where it has more connections and stuff on there. I don't think so. I don't think it is. There is a circuit board there. Still not drawing anything. Hope I'm not going to blow this now. Right, let's go up to 12 volts. Right, 12 volts. Weird, it's not drawing anything, it's not doing anything. Okay. Right, maybe it's not 12 volts. Could be a problem with the board up here, not providing the voltage down to it. But why can't we get that motor to work? So how do I take the motor out? Actually, you know what I'm going to do? Let me spin it and go on to millivolts and see if we can generate any electricity from it. So if I go to millivolts here and go on here and here, no. Let me go to resistance. I'm getting confused now. I suppose, mind you, I don't want it to overheat. I was going to say we could have it so that the element, you know, if I could go across here and see 12 volts all the time, then we know that this is definitely faulty. My worry is that it might overheat very quickly when it's on the mat. So I think the relays are for the 2 different heat settings, because we have low and high. We have like eco mode and 1500 watts, 800 watts and 1500 watts. So I think that's what they're for. I've got a fuse there, but that's going to be working because I can feel heat. Yeah. We really need to know if there's 12 volts getting here or not. I think I am going to have to turn this on. Keep my hands well clear of all the mains here. See the bridge rectifier, see the massive cap. Let's just make sure there's no power in that cap. 16 volts, that's okay. Thing is, if we go to here, why are we not getting a coil reading? That's not right, is it? We should be getting a coil reading. I'm just wondering what that circuit board is down there. Rather than risk doing something dangerous, I think I'm going to see if I can get this out to see what that board's doing. Wow. Oh my word, that was so much easier than I thought. So there we go, that's the huge heater here. Should it be loose like that there? That don't seem right. Doesn't it? That doesn't seem right at all. Why is that not pushed all the way in? Also, we got burnt bits of plastic. No wonder I was smelling horrible stuff. That's not right at all. Can you see we got like lumps of burnt plastic here, here, and it's all higher than the bottom bit. Can you see it's clipped in here? But why on earth would it be clipped into the plastic like that? Not sure about that, you know. That doesn't seem right. Unless, of course, because it's been on without the fan, it's overheated. I think that should be a lot further in. I think the plastic there belongs to these edge bits. Don't know. Anyway, let's forget about this for the moment. Let's turn our attention to the motor. Now, what are you doing? So we have a couple of screws here. Hopefully that will then maybe drop down a bit. There. Are you going to come out? Is it on a rubber bung? How are you attached? Yes, you're on a rubber bung. Okay. Well, we know that that's spinning nicely, so it's not... Whoa, 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 Vince. Whoops. Cable tied on. Okay, we'll just leave it there. So now, why are you not working? So I need to pull that off, I think. There. Whoops. Let me take some pictures of all this, because otherwise I'm going to put it on wrong. Okay, so what we got here, rubber O-ring here, some grease there, presume that's all normal. The other thing spins around this. How do I get you out? Right, the coils are going down through these two, I think, and that's linked to that one, linked to that one. So I think if I went across here and here, I should be able to get a resistance reading. Because if you have a look, you can see the enamelled wire just here and here, but then when I go this side, there's no pole here at all, and there's no enamelled wire there. So I should be able to get a reading between these two, and that will tell me if the coils are okay. Because if it's open, it means the coils are damaged. No, 5 ohms, coils are okay. So what's on this circuit board, which is, I don't know what's going on with the circuit board. It looks like there's some sort of chip here. I can't take this off, annoyingly. It's like it's glued down. Well, I can see legs of that tiny little component just there, little black thing just there. But I'm not getting anything through here. I wonder, I wonder, is this connector doing what it needs to do? I might just try to jab the wires to see if we're getting something. So I'm on the red one. I might try to just pierce through. Yeah. The black one. Yeah. Are you okay or are you not? I think I'm going to have to go back. How about if I've got an idea. How about if I go back and disconnect the heater? I think the fan will still come on, and then I can measure 12 volts on there, and that will tell me, because the only thing I'm bothered about is the heater burning out. But if I disconnect, if I take another picture, disconnect these, then the heater's not going to go on. And I can measure 12 volts on here. So I've just got a pinch, there's a little pinch thing here that I have to pinch in order to pull this out. There we go. That little thing there. Right, let's just make sure this board's still going to get power. Right, so that's completely disconnected. We've got the black wire coming up to here. We've got the red wire going down to this safety cutout thing, which then comes back on this black wire. So this board here is going to be getting power. So if I connect this up again, I think we should be good to measure 12 volts here, making sure I do not touch these here, because they're going to be live, so I've got to be so careful now. So careful. Don't copy what you see in my videos. If I accidentally touch them and they are fully exposed, then I will be electrocuted. I think I'm alright to turn this on. Let's have a look now. So that's going to give it power. I'm not going on here, even though they're going to be live. I just need to go onto these prongs here, very carefully, on 12 volts. So I should be able to access it on the low voltage side, just here and here, like so. Let's do it. Plugging it in now. P4 it's saying. Oh, it's got a tilt switch. That's annoying. It's got an anti-tilt switch. You know, where if it falls over it will stop. It's just going to make things harder. Alright. Whoa. That's live. Be careful, Vince. Well, it's not live, but I mean it's still going to have power and a capacitor. Right, how am I going to do this now? That's wobbling everywhere. Right, I might be able to do it from here. I think I can do it from here. For all I know, that could be, it's got a cap next, it has to be DC. Right, let's plug it in now. That's not going to short, Let's see what it's doing now. What's it saying? Okay, that's good. So let's turn it on. Right, I heard a relay go. Very carefully. Volts all the time. 100%. The motor's failed. You can see there 12 volts. Going to do that one more time. So the motor has failed. So I've got no option but to go into it. Turn it off. Let's just make sure now that there is no 12 volts. That should drain away soon now. There you go. Now it's gone. Okay, unplugging it. Still got to be careful because it might be charging the big cap. Let's measure the big cap. No, down to 17 volts. Okay. Well, I'm happy to put that to one side. I now know that this is okay. We have a problem with the motor, and I think it's a problem from manufacture. So I'm not quite sure what I'm going to do, because I think this is going to be completely destructive. So annoyingly, it's all sealed. There's no way of getting to the circuit board. I think what this is here, I think it is a brushless motor. It's fed with 2 wires, and then all the clever brushless bit is done on the little circuit board on the actual motor itself. So, you know, with the Hall effect sensors and that sort of stuff. Now, what would you do here? You've seen that I tried putting voltage in. 12 volts, 8 volts, 5 volts. I was putting the positive wire from my bench power supply onto the red lead, and I was putting the negative wire from the bench power supply onto the black lead. So as far as I'm concerned, I've done everything right. Is there anything that you would do differently? Because some of you might be shouting at the screen, but I don't think you are, because I think you would also be putting positive into the red lead and you'd be putting negative into the black lead. Also, have a look at the actual magnet part of the motor that does the spinning. It's greasy, isn't it?
very, very, very greasy. Obviously, I'm coming to this now after I know what the problem is, but at this moment in the video I didn't know what the problem is. So I just want to highlight the fact to maybe give you some information now to maybe look for stuff that may have gone wrong or be affecting the motor. But what I'm doing is I'm attacking the motor with my little cutters to try to get into it, because I have to get into the actual circuit board to see if I can find out what's going on, because as far as I can see we've got 12 volts going down the wires into the motor, yet the motor isn't doing anything. So there must be a fail component on the circuit board, correct? Let's see. Alright, what we got? Okay, we've got a resistor tombstone. That clearly was me when I was putting my probes in there. So let's try to get that back down. It's like keyhole surgery. Right, okay. I think that's on. Should we start measuring? I'm just going to go on continuity to begin with. And I'm going to go on the red lead. So red lead's coming to here. Yes, which goes to where? Here. Doesn't go through there. Maybe that's correct. Looks like it goes through to here. Yes. Okay, now let's go on to the other lead. Black lead goes to here, which goes to this diode. So should we measure the diode? Now there's something that's really obvious to me now that I know the answer, but some of you may have seen. We have the red lead going to board and the black lead going to the board. And this board is actually labelled up. I've never seen it at the time. Anyway, I measure a few components, can't find anything wrong. So I've convinced myself that I need to cut away more of this motor so I've got a clearer view of all the components. I hope this isn't, you know, I hope from manufacture there hasn't been wires missed off this. Like there should be another 2 coming off here. For P&F, whatever that means. Please look closely, it's glaringly obvious when you look at the circuit board. Look, 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 and see if you can spot what I didn't spot. So I think what I'm going to do is, I'm going to put 12 volts in and I'm going to see if there's 12 volts coming up between here and here. Because we've got a direct path going through here, here. So the middle one's that, and this side's going to be negative. Hold on a minute, just noticed something. I know it's unlikely, but red, I would presume, means positive, and black would be negative. Haha, who spotted it? I bet there's hundreds, if not thousands, that did spot it. I should say something like, hit the thumbs up button or subscribe if you spotted it. And that way then I'd probably get a load more subscribers and thumbs up and YouTube would push this video. Anyway, I never spotted it. I never spotted it. Red should be positive, black should be negative. That's what I always thought anyway. Weirdly though, this black wire does have a stripe of red on it. Yet the red one is going to the negative here and the black's going to the positive. I wonder, is the diode stopping the power from going through because this has been soldered on the wrong way? Should I just try swapping them over? Just in case? Will we do any damage? Well, I'll tell you what we could do. Why don't I do my bench power supply the other way? And then it will put the voltage in here. That's what we'll do. We'll use my bench power supply. And we'll see if we get a twitch out of it. I'm going to lower it down a little bit just to 10 volts. Might cause a little bit less damage. We'll keep this correct on here, but we'll put them on the opposite way around. So now we are going to be going positive here and negative here. Shall we see if it does anything different? Will we get something out of it? No. I'm still not drawing anything.
Whoa! We got something. We got something, did we not? Let's try that again. There you go. Let me go up to 12 volts, see if it works straight away. That'll be interesting if that's the case. I didn't spot that at all. This keeps shocking me. How am I gonna hold this so I can actually see it spin? Should I get the vise? Put it on there, then I might be able to see it spin. Because remember, it did do it a tiny little bit in at the very beginning. Beginning of the video, remember it gave a little spin. And here. Look at that. Look at that. Oh, it's really ramping up. Now, I presume it didn't blow before because there was voltage going in before. I'm just going to go this way just to make sure. There you go. They've soldered it up wrong. I presume the board is correct. Amazing. What an amazing fault, a manufacturing fault. So this never works. Oh, I feel quite proud of finding that. Even though it's super obvious. It's only super obvious when you know. How many people were shouting at the screen? How many of you noticed that? Let's leave this out a minute and let's get it connected up properly. How nice is that when it goes spinning? So I didn't actually need to take it apart if I had known, but I wouldn't have known. All I would have had to do is try to take the wires out from here and put them the other way in here. Yeah, that would have been the same, wouldn't it? Because then the positive would have been going on the other one. Okay, let's unsolder them. Interesting. I hope now, when it's actually in, it's blowing air through the correct way and not the opposite way. Do you know what I mean? I hope it's not putting air through the back of the fan. So that protection diode must have been doing its thing and blocking the power from getting to that chip. Oh, I thought that was interesting. Right, what am I going to do here? What am I going to do here? I think I've got room underneath. I'm going to have to make some sort of plastic plate, aren't I? That'll be easier said than done. Actually, before I get too involved with that, we really should connect it up to the board and see if it starts working. Right, it's probably going to be as noisy as hell and as bodgy as hell. I just want to see if that if it works. So I think that's not going to short against anything. They're all disconnected. So we should be able to see that spin. I'm going to plug it in now. Hopefully nothing will short. I think I'm okay to do this. Right, we're in. And on. Come on. Why are you not spinning?
Ha ha.
Why are you not spinning? That's worrying. Well, I wasn't expecting that. Good job I didn't put all the plastic and stuff back on it. So, what's... why is that not working? So I suppose I have to measure voltage underneath it now, if I can, and see... My hands are going to be in the way. And see, you know, which one is live, because, you know, 12 volts. So the red one now is this side here. So we should be able to see which is 12 volts. So I'm going to plug it in. Turn it on. So it should be working now. Very carefully. That's minus 12 volts. So they had it correct. That's 12 volts that way. Okay, 1 second now. So they had it correct. Let's turn this off. They had it correct. What does this mean now? They had it correct. So 12 volts is travelling up the red and black wire, and negative is on the red wire, and now I've put it the opposite way around. So if I swap it back, it should work. No, hold on, I'm getting really confused. Why is it only working one way or not the other way? There we go. Right, so I should be able to get my head around this. I can't be that stupid, can I? We know it's working that way. Why is the fan working the wrong way? So we have got, at this moment in time, 12 volts coming up the black wire, which is this one here. Okay, so I just have to swap them over now. So what was the problem? Let's take this off completely. I'm going to inject voltage directly into this. Somehow it might have just started working. Because that doesn't make any sense. Right, so this can spin here now. I'm going to put the voltage in the correct way from my bench power supply and see if it starts spinning. Yes. Okay, so in theory when I put it on the wrong way, with this, it should now work. Unless, of course, is it to do with a current thing? I'm going to put the current right down. Maybe there's something on my meter on the fan which isn't working because it's such low current. So now I'm down to 460. Well, we know it's only drawing 180. So let's lower it right down. Let's see what happens at 64 milliamps, which is a third. No, it still goes. Oh, but then stops and starts, look. But it still goes. Ah, is there something wrong with the board? Because remember, it did go once. Maybe it's not putting through enough current. Okay, let me lower it down even more. Right now we are at 43 milliamps. Look at that. But maybe the board shuts down because it recognises that it's not happy. I'm not sure. Either that or it's just started to work. Let's solder it back together like it was. So I'm soldering it back on the way it was originally, which is the red wire to the negative and the black wire to the positive. But remember, this was returned to Amazon because it wasn't working, and in my ownership it hasn't been working. So why now is it working? Let's solder these wires on, put it back into the machine and see if the fan is spinning, or is it still just doing a little glitch, then nothing, and a little glitch as it turns off. Right, it's very dodgy because it's loose here, but let's see now. Are you going to work? Turn it on just out of shot. Yes. Right, turn it off. Oops. Turn it off. I just turned this thing off. Why is it still going? How long did you go for? That's worrying. Oh, now it stops. Okay, maybe it keeps going for a bit. Well, we know that there's still going to be 12 volts in the board, and maybe it needs to kind of blow the heat away from the heater. I just want to try that one more time. And now I'm going to turn it off here.
what's going on? As far as I can see, I haven't done anything to that board to make it work. The motor, I mean. The motor board. That's really, really strange. It is strange, isn't it? So, to begin with, nothing was working, and now it is working. And all I've done is taken the motor apart, put voltage in the wrong way, and then put it back into the board, and now it's working. At the very beginning, if I had put the positive voltage into the black wire and the negative voltage into the red wire, then I'm pretty sure it would be working. But please educate me. Maybe a black wire with red down it does denote positive. Really not too sure. Anyway, what I have to do now is try to get this motor back together. The rest of the video is actually interesting. It's just that I'm already over 40 minutes and it's an Advent challenge video, so I have to keep them shorter. What I do is I get some plastic, cut it to shape, and I glue it all into place. There is quite a bit of movement because the axle of the motor is quite long. We don't need a huge amount of it going up into the fan spinning blades itself. So the repair I do, although it looks bodgy, I'd never sell this, but I'm more than happy to use it myself. So yeah, it takes quite a while to get the motor fixed up. Now, I actually know what the problem is, because there's another one of these in the pallet, and in a future episode I look at it, and this time I don't mess with the motor because I know to put positive voltage into the black wire and negative voltage into the red wire. And what it's doing is I don't really want to give away too much, because the thing is it's going to spoil the next video. So, but at the same time, I don't want you to feel annoyed at this video not knowing the answer. So in this video, I have zero idea why this started to work. In my mind, I thought maybe I kick-started something. You know, maybe by putting power in, I accidentally shorted one of the components on that motor board, and now it's just working. Believe it or not, what I think the problem is, and I think it's probably affected quite a lot of these, is, do you remember when I took it apart to begin with, there was lots of grease on the magnet part of this motor, the spinning part? Well, when it comes to the other fan, I cleaned the grease off and it works perfectly. Please still watch that other video because it's interesting in its own right. I think what I did here is, without even realising it in the video sometime, I was probably getting sick of getting grease all over my fingers, so I wiped the grease off the magnet part of this spinning motor, and in doing that I made it work. The problem that I've done here is that I was putting voltage incorrectly into it, but I thought it was correct. If I had swapped the polarity at the beginning of the video and put plus 12 volts or plus 5 volts or plus 8 volts or any amount of voltage into the black wire and then the negative onto the red wire, then this motor would have probably twitched. And then if I'd cleaned it, I'm certain it would have started working. So yeah, the rest of the video is quite good, the way I fix up the motor and stuff, but there's nothing that much to see. So what you're going to see now is me putting it back together, and then yeah, I'm going to show you it working at the end.
Right, here we are, quite a few weeks later, and I've been using this every single night, late at night, when the heating's off and I don't want to put the heating on to heat up the whole house. When I'm doing my editing, I just put this next to me here, and it's been working perfectly. So I wasted a huge amount of time on here because I didn't think to put reverse polarity into the motor. Let me know if you think that's quite normal, or do you think it's not normal? Or does a black wire with a red stripe actually mean positive? Maybe it does. Maybe that denotes positive, and maybe everybody knows that apart from me. I put a new battery in here, remote control's working, everything on here is working perfectly. And although I wasted a huge amount of time on here, it allowed me to fix up this next one that you'll see in a future video really, really easily. So the knowledge I gained on this, not that I'm gonna go into fixing these for a living, but if I had another 20 of these, the knowledge I gained on this one here would make it much easier to fix the other 20. So I've seated the heater back into place. I've bodged up the motor, but I feel confident using it myself. I would never, 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 never give this to anybody else to use, but I feel confident using it myself because I understand it and I know it's not going to be as good as one that left the factory. But at least this one is now working, and when it left the factory, it didn't. So it's doing what it needs to do. Check this out. And it's every single time. What I like is the oscillation up and down and left and right. So if I turn it on, you will hopefully hear, let me get a bit of tissue, so you can see the wind blowing. It gives off a nice bit of heat. Watch this. There you go. Hopefully you can see that. And back again. Yeah. And if I do oscillate, it does that way. And if I do oscillate on this one, it will go the other way. So what's nice is it does both of them at the same time. So it's going left and right and up and down. So it does kick the heat around quite nicely. To me, it sounds as quiet as the other one that I fixed. So I can't see a difference between them. Now, I know it sounds ridiculous, and I'm not saying I'm definitely right, because maybe with the other one, by me cleaning it, I inadvertently fixed something else. Why would grease stop it from working? Is it something to do with it not being recognised? That little chip that you've seen on the, I'm going to call it a brushless motor. I'm sure it's a brushless motor, but even that I can't say with 100% certainty. Is the chip the thing that's reading the magnet going round, the magnets going round, and that's how it knows how it's working? And if there's grease there, is it stopping the chip from reading the magnet because the grease is in the way, which is somehow interfering with it? Really weird. But you can see in this video here, all I actually did was take apart the motor and put it back together again. So none of that would have fixed it. So that's why there's a lovely bit of heat coming out of this. So that's why I'm saying that it's a grease problem. But please watch my other video. Don't just turn off that one, because that one is more interesting than this one, because that's where I actually kind of like discover what I think the problem is. But if I'm incorrect, and there's a good chance I am, put down what you think in the comments section down below. Also, if it turns out, which I hope it does, that a red wire always means positive and black, even if it's got a red stripe, is always negative, then what I've learned is to always check polarity. Never assume that that is what it is, because without taking apart the motor, we would have never seen that the black wire was on to positive. Yet if I had swapped polarity on my bench power supply, then the motor would have twitched into life, and I would have saved myself so much time, not only in fault finding, but also I wouldn't have had to put together the motor again. So there we have it.
Summary?
My first 0 day here. Although this fan is working well, there's no way I could sell it, and I wouldn't even give it away to friends or family, because it could be a dangerous item if that fan stops spinning. I know it's got protection for overheating and stuff, but still I wouldn't feel confident giving this away to anybody. But yeah, it's something I'd use myself. But as far as this challenge is concerned, I'm going to put it down as a 0. Anyway, let's move on to day 9 tomorrow and see what that brings.